Hello and welcome to my channel. This video is about factoring quadratic equations. If you like and enjoy these helpful videos, please hit that subscribe button as well as the like button. Thank you. This part will deal with factoring quadratic equations of the form x squared plus bx plus c, where the coefficient of the squared variable is an understood 1. To factor these types of quadratic equations, you should ask yourself the following question. What are two numbers that multiply to c and add to b? So this means that within the trinomial, the constant term, or whatever is last, when the quadratic equation is written squared term, x to the first power term, and constant term, they always multiply to the constant number and add to the middle number. So again, that question is, what are two numbers that multiply to c and add to b? So you're looking for two factors of c, including different combinations of signs that will add to the middle coefficient b. So for our first problem, we'll factor x squared plus 3x plus 2. So, what are two numbers that multiply to 2 and add to 3? So think of two factors of the number 2. Factors are numbers that multiply to give a given number as an answer. So in this case, we're looking for the factors of 2. They happen to be 2 and 1. And what is 2 plus 1? Well, that adds to 3. So we've found our numbers. Now, when we write factors, you always have quadratics always factor as a pair of binomials. Binomials have two terms each. You'll need to enclose them in parentheses because parentheses beside each other mean understood multiplication. So x squared, that's just x times x. Now we just fill in our numbers in either order. So it could be x plus 2 plus x plus 1, or x plus 1 times x plus 2. And either of these answers is equally correct. Let's factor x squared plus 13x plus 36. Please pause the video and then restart once you have an answer or if you have any questions. Now let's ask ourselves the factoring question. What are two numbers that multiply to 36 and add to 13? So now think about factors of 36. 1 times 36, well, that's too big. 2 and 18, no. 3 plus 12, no. 4 times 9, bingo. How do I know that is the correct one? Well, 4 times 9 is 36. 4 plus 9 adds to 13. So these are it. 4 and 9. So we write our pair of binomials. We've learned that x times x is x squared. It does not matter the order that you write the two number factors within the binomials. So one possible correct answer is x plus 4 times x plus 9, or x plus 9 times x plus 4. Both of those answers are equally correct. Okay, let's factor x squared minus x minus 6. Now note that the coefficient of the x in the middle, the negative sign, represents -1. So for our factoring question, it will be what are two numbers that multiply to -6 and add to -1. Now remember, you can include signs with factors. So this one would be -3 times +2. Because how do I know that's it? Because what is -3 plus 2? -3 plus 2 adds to -1. So our numbers are -3 and +2. So we form our pair of binomial factors. First we start with x because x times x is x squared, and -3, +2. So there's one form of the correct answer, or this could be written as x plus 2 times x minus 3. And both of those are equally correct answers. Let's factor x squared minus 2x minus 35. Please pause the video and then turn it back on when you have an answer or if you have some questions. Now let's ask ourselves the factoring question. What are two numbers that multiply to -35 and add to -2? So think of factors of -35. Well, there's not going to be a lot of them here. It's 1 and 35 and 7 and 5. Bingo, those are 2 apart. Now, what should the sign of the 7 be? It should be negative, and the 5 would be positive, because they have to add to -2, because -7 plus 5 adds to -2, just like we need. So our two numbers are -7, +5. Let's write out our binomial. So it'd be x minus 7 times x plus 5, or x plus 5 times x minus 7. And either one of these answers is equally correct. Now let's factor x squared minus 7x plus 12. So here when we ask the factoring question, what are two numbers that add to or multiply to +12 and add to -7? So let's think of factors of 12. We got 1 and 12, 2 and 6, 3 and 4. That's all of them. Well, clearly it's 3 and 4, but the 3 and 4 have to both be negative, because -3 minus 4 is -7. Now think about this. What is -3 times -4? That is +12, because a negative number times another negative number is a positive number. So these are it. So the numbers are -3 and -4. And we can write this as x minus 3 times x minus 4, or x minus 4 times x minus 3. Either one of these answers are equally correct, and that's due to the commutative property of multiplication, which says that it does not matter what order you multiply your factors. As long as all of the multiplication work is done correctly, you will obtain the correct answer. Let's factor x squared minus 16x plus 63. Please pause the video and turn it back on when you need to check your answer or if you have any questions. So now let's ask ourselves the factoring question. What are two numbers that multiply to positive 63 and add to negative 16? Let's think of factors of 63. 1 and 63, that's too big. 3 and 21, too big, because the difference is 18. And then we have 7 times 9. Bingo, that's it. Because negative 7 minus 9 adds to negative 16. And negative 7 times negative 9 is positive 63. So the two numbers are negative 7 and negative 9. And we can write that answer as x minus 7 times x minus 9, or x minus 9 times x minus 7. Both of these answers are equally correct. Now let's factor x squared plus 5x minus 14. So we ask ourselves the factoring question. What are two numbers that multiply to negative 14 and add to 5? So think of the factors of 14. 1 and 14, too big. 7 and 2, bingo. 7 minus 2 is 5. 7 is positive, 2 is negative. And then positive 7 times negative 2 multiplies to negative 14, so those two check out. So our factors are positive 7 and negative 2. So we can write that answer as x plus 7 times x minus 2, or x minus 2 times x plus 7. Now we're asked to factor x squared plus 7x minus 60. So let's think of factors of 60 that are 7 apart, or these two factors of negative 60 have to add up to a positive 7. There's 1 and 60, too big. 2 and 30, too big. 3 and 20, too big. 4 and 15, still too big. 5 times 12, bingo, those are 7 apart. The 7 is positive, so this means the 12 is positive, the 5 is negative. 12 minus 5 is positive 7. 12 times negative 5 is negative 60, so those are our pair. Positive 12 and a negative 5, so we write the answer, x plus 12 times x minus 5, or x minus 5 times x plus 12. Either of these answers are equally correct. Now, this part of the video deals with factoring trinomials of the form ax squared plus bx plus c. And we have to modify our factoring question because the coefficient of the x squared variable is no longer 1. So that question would be, what are two numbers that multiply to AC? So you multiply the leading coefficient A times the constant term C and add to B. So they still add to the middle term. Now let's factor the trinomial 6x squared plus 7x minus 20. So when we ask ourselves the factoring question, what are two numbers that multiply to? So we multiply A, which is 6, times negative 20 for C, 6 times negative 20 is negative 120. So what are two numbers that multiply to negative 120 and add to 7? So these are a little more challenging, often because that multiplication product is often large numbers. So let's think about pairs of numbers that multiply to 120. Well, 1 times 120, too big. 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 7 does not evenly divide 120, and then we have 8 times 15, bingo, those two are 7 apart or have a difference of 7 between them. So to get the correct signs, they have to add to a positive 7. So it means the 15 is positive and the 8 is negative. That adds it to positive 7. They would have positive 15 times negative 8. That is negative 120. Now we have to modify our factoring method just a little bit here. What you do with this technique is you decrease the degree of the 6x squared term by 1. You keep the coefficient of 6. So in that first position, we'll put 6x and 6x. Now write in your factors. It doesn't matter where you put it. One is positive 15. The other is negative 8. Now we'll divide out common factors from each of these. So the first one is common factor of 6 and 15 would be 3. So that answer would be 2x plus 5. And then 6 and 8, greatest common factor would be 2. So this would be times 3x minus 4. So there's one way to write that answer, 2x plus 5 times 3x plus 4, or 3x minus 4, or 3x minus 4 times 2x plus 5. Either of these answers are equally correct. Let's factor 21x squared plus 22x minus 8. Please pause the video and then turn it back on when you have an answer or you have a question. So now we ask ourselves a factoring question. What are two numbers that multiply to 21 times negative 8? That happens to be negative 168. And they add to positive 22. So there's a difference of 22 between these factors. So it's like a factors of 168. 1 and 168, too big. 2 and 84, too much difference. 4 and 42, still too big. 8 and 21. That's not what we want. 3 and 56. Nope. How about 6 times 28? Bingo, there it is. So I need positive 22, so this would be, 28 would be positive. The 6 will be negative. 28 minus 6 is 22. And 28 times negative 6 multiplies to negative 168. So that checks out. So remember, we have to modify our factors. We drop the degree of the leading term by 1. So instead of 21x squared, we write 21x in the first term. And then this will be positive 28, and then negative 6. The order that you write them for the factorizations does not matter. So 21 and 28, there's a common factor of 7. So that would be 3x plus 4. 21 and 6, common factor of 3. So that is 7x minus 2. So that's 3x plus 4 times 7x minus 2. One way to represent the correct answer, or 7x minus 2 times the quantity 3x plus 4. Now let's factor 15x squared minus 8x minus 12. So we ask ourselves the factoring question, what are two numbers that multiply to 15 times negative 12, so that is negative 180. So what are two numbers that multiply to negative 180 and add to negative 8? Now we need to think of factors of 180 that basically have a difference of 8 or are 8 apart from one another. So 1 and 180 is too big, 2 and 90, too big, 3 and 60, too big. The 4 and the 5 I'm not going to bother with. Let's just go to 8. 8 times, or 18 times 10. There we go. That's what we want. So since the middle is negative, the 18 will be negative. Negative 18 times 10 is negative 180. Negative 18 plus 10 adds to negative 8. Those are our two numbers. Negative 18, positive 10. Remember, we have to decrease the degree of the leading term by 1. So instead of 15x squared, it'd be 15x, first position. Then minus 18 plus 10. Take out the common factors. So the common factor, greatest common factor of 15 and 18 would be 3. So that reduces down to 5x minus 6. Biggest number that evenly divides 15 and 10 is 5. So that is 3x plus 2. So that's one way to write the answer. Another way would be 3x plus 2 times 5x minus 6. So either of those are equally correct answers. Now let's factor 16x squared minus 2x minus 3. So we need to ask ourselves the factoring question. What are two numbers that multiply to 16 times negative 3? Well, that's negative 48. And they add to negative 2. So think about factors of 48 that are 2 apart. 48 and 1, no. 2 times 24, too big. 3 times 16, too big. 4 and 12, too big. 6 times 8, bingo, because 8 minus 6 is 2. They're 2 apart. Now the 2 has to be negative, so that means the larger digit of the factors, the 8 has to be negative, because negative 8 plus 6 is negative 2. Boom. So our numbers are negative 8 and positive 6. And when we write out our factorization initially, we have to, the first term is always the leading term, degree decreased by 1. So instead of writing 16x squared, we write 16x. And just put negative 8, positive 6. Now factor out the greatest common factor from each one. Biggest number that even divides 16 and 8 is 8. So that is 2x minus 1. And the largest number that evenly divides 16 and 6 is 2. So it would be 8x plus 3. So this is 2x minus 1 times 8x plus 3, or 8x plus 3 times 2x minus 1. And those are both equally correct answers. Thank you for watching my video, and please feel free to make comments for suggestions for future videos or how I can do things better. Thank you.